Term 2 revision sheet question 16. So I'm just going to take you through first of all this optimization question, but I will take you through 4 eventually. So the first one is quite well scaffolded, so you just need to step through. If I was doing this as one single question though, notice that part C asks to determine the maximum volume. So I'd be thinking straight away that I need to get volume as a function of one other variable, and I'd be aiming for that through my relationships, eliminating variables so that I can derive and maximize the volume, and in all likeliness in terms of x. So let's have a read of the question. A cuboid has a total surface area of 150 centimeters cubed with a square base of side x. So my cuboid has a square base first of all, and a side length of x on that square base. And obviously, reading the second statement, this cuboid has a height of h. So that's not a very good line, but we'll go with it. A height here of h, and you can see there's my cuboid with a height of h. Question A shows that the height of the cuboid can be given by that function. So let's have a look at question A. First of all, I know that, and I'm just going to state the relationships like it's a normal optimization question. I know that the volume is equal to hx squared, and I'll call that relationship number 1. And I know that the surface area is equal to, first of all, 2x squared, and that will give me the base and the top, plus 2hx, which will give me this side and this side, so the two sides, and then another 2hx in this case, which will give me the front and the back. And that simplifies down to 2x squared plus 4hx. But notice also that the surface area is equal to 150. So I can write down 150 equals 2x squared plus 4hx. And simplifying this now to write it in terms of h, I'm going to take away the 2x squared, swap the sides at the same time to give me 4hx equals 150 minus 2x squared. I'm going to divide by 4x to give me h equals 150 minus 2x squared all over 4x. And that can obviously be simplified by dividing everything by 2 to give me 75 minus x squared over 2x, and that's what's required of me there. Now if you've got a scaffolded question like this, obviously you know where you're aiming, so you can use that to help you a little bit. 16b, express the volume of the cuboid in terms of x. So next I get my volume relationship, v equals hx squared, and I recognise that I need to write it in terms of x, so I need to substitute out what h is equal to as a function of x. So I get volume equals, and instead of h I'm going to put in my 75 minus x squared over 2x, and then that's multiplied by x squared. And that comes from what h is equal to there. Now I'm going to simplify this term. One of the x's on the outside cancels the x on the base. 75 divided by 2 is 37.5 with an x, that residual x at the front there, minus a half x cubed. So now I've got my function as a function of x, and question B actually states express the volume of the cuboid in terms of x. So I'm very happy with that. Question C asks me to calculate the maximum volume. So to calculate the maximum volume, I need to find a turning point. That's where a maximum will happen. So dv dx is equal to 37.5 minus 3 over 2x squared. It's a bit weird here that I'm using a fraction and a decimal, but it kind of suits my needs, and it doesn't matter too much as long as I'm clear and I'm not rounding, keeping my answer exact. Okay, now we know that we'll get a maximum, or a turning point will occur when dv or v dash dv dx is equal to 0. So I get 37.5 minus 3 over 2x squared, and I need this to be equal to 0. So now I go ahead and solve this equation. 3 over 2 x squared equals 37.5. X squared is equal to 25. So I multiply 37.5 by 2/3. And I take the square root and I get x equals plus or minus 5. It's always good to recognise that when you square root you get a plus or minus answer. But obviously here x is a length, so x cannot equal negative 5. So I've got x equals 5. And if x equals 5, then obviously v is equal to 37.5 times 5 minus 3 over 2 times 5 to the power of 3, and that's equal to 187.5 minus 3 over 2 times 125, and once calculated that equals 125 centimeters cubed. My apologies, that's not 3 over 2, that is of course 1 over 2 times 125, and that's equal to 125 centimeters cubed is the maximum volume. Of course over here I should be checking that this is indeed a maximum, not a minimum, and we're pretty comfortable that it is, but just to check really quickly, d squared v dx squared is equal to negative 3x when I derive dv dx, and at x equals 5, then d squared v dx squared is equal to negative 15, and if it's negative that implies that we're dealing with a maximum value. And of course you might need to go back and state your solution in terms of the context. Anything else that is needed now you should make sure that you do. Question 16 done.